Hey guys, today I want to talk to you about one of the most beautiful concepts in calculus, and that is the derivative. I really enjoy explaining this concept to people because I think it's just very clever. It's just very beautiful and clever, and I don't know. I just really enjoy explaining this. Okay, so I just want you to know that the derivative is not hard at all. Okay, we're not gonna go over complicated algebra that you have no clue what the hell you're doing. I'm just gonna show you the beautiful part of it, okay? Which is the most fundamental thing that you need to know in order to understand what a derivative is and how you can interpret it, okay? So let's dive into it. So before you start getting scared about, well, what the hell is a derivative? It's usually like that word all mathematicians use to explain weird things. No. Let me show you something pretty cool. This equation that the slope of a line is going to be equal to y2 minus y1 divided a change in x. This equation right there, which I'm pretty sure all of you are very familiar with, this is a derivative, okay? Now, someone more advanced in math would probably not define this as a derivative, but they would see why I'm saying this. This is a derivative because it is describing change, okay? Derivatives describe change, okay? So I'm going to show you what I mean by that. So I'm going to erase this. Now I'm going to show you the geometric, or you could say probably the coolest part about derivatives, okay? And it's why I enjoy explaining this. So let's suppose we have a graph. And I'm going to say it starts here, and it goes all the way here, right? Now we know here we've got our output, f of x, and here is going to be x. Now, I want you to think, when we have a slope, we generally refer to a line, right? So we say that, for example, we've got maybe these 2 points, and there is a line between these 2 points. And you could say that the slope between them would be, if we say this is going to be equal to x1, comma, y1, and this is x2 up here, I'm sorry. This is x2, comma, y2. You just simply take the change in x. So for example, if we were here, we had to move a distance to the right side, and that net distance or displacement, you could say in terms of physics, would be just simply equal to x2 minus x1, right? And now the top part, or how much you moved on the top, or your rise, as they like to call it, rise over run, would just simply be y2 minus y1, okay? Now, we're getting close to a derivative in here, okay? Now, I want to ask you something. Keep this in mind, okay? Keep the concept of a slope in mind. If we have a curve, I'm going to say a curve like this. Yeah, I think that works. And now, let's say, for example, that we have 2 points. We're going to say that we have a first point in here. This point is going to be x. And now we know the output. We haven't defined the function yet. We could say it's maybe x squared. And we're going to say that that output is going to be f of x, okay? Pretty simple, right? Whatever number x is, the output is just simply going to be the function evaluated at that x value, okay? It's pretty simple. Now we have that point in there. Now I'm going to place another point that is going to be h units. So it's going to be, I'm going to say this point is actually maybe a bit less, probably here. This point is h units away from our x point. And now how much would that be? Well, we know that would just simply be x plus h, okay? And now what would be the output? Well, we know, let me get this together so you guys see it. The output in this case would be equal to f of x plus h, okay? If you have a number, let's say x is equal to 10 and h is equal to 2, well, you know, f of 10 would be simply f of 10, the output. And you have 10 plus 2, that's just gonna be 12, so the output would be f of whatever the addition gives you between those two values, okay? So this is what this notation means and what it has to do with this. So these are 2 points that we have. Now, the cool thing that I want to show you is the following. What if you wanted to describe how much the function is changing in between those 2 points? One thing you could do is to use a line, a slope. In this case, you would need a line that connects these 2 points. Okay? We could say it's this blue line. Now, a very important concept that you need to know right now is that this is called a secant line. So a secant line, like the trigonometric function, is a line that if you have, for example, a circle and you cross a line between the curve that circle creates, or its circumference, if it crosses 2 points of that circumference, it's going to be a secant line, okay? So now this is a secant line that is its slope. So in this case, this slope, you could say how much is the slope of this line? Remember, you need 4 values. We have those 4 values. What is y2? In this case, y2 would be equal to f of x plus h, right? So if we wanted to compute the slope between those 2 points, or you could say the net change in this curve, you just simply use the equation that you know. y2 minus y1 divided by x2 minus x1. Okay, it's pretty simple. But now I want to show you something pretty cool, and here's where the fun starts. So what if we said that we wanted to compute the limit when h is very, very, very close to 0? So what I'm trying to say is that we can see how much the function is changing because we're doing a rise over run in this interval. But what if we know that interval is h units big. What if we made that interval infinitely small? So if we said that the limit as h approaches 0, basically what we're doing is that we have a curve, and this curve has 2 points, and they are, oh well, that sucks, I'm going to say a point is there. And now I'm going to say we want to bring these 2 points together, and they are a secant line. So if we bring them together, so if we say that the distance between those 2 points is getting closer and closer to 0, what we're basically doing is that we're going to make those 2 points meet in one place. And that place would give us a tangent line. Now remember, a tangent line, in this case, if you don't know the term pretty quick, don't be scared by its name. A tangent line is just simply, if you have a curve, I'm going to say circle, and you have a line that only touches, that barely touches this circle or this curve that the circle have, this is a tangent line, okay? And that is basically what we're doing here. We have a secant line with 2 points, x and x plus h, and its outputs, and we're trying to bring them together so that we can find not the net change between pretty big values, between x and x plus h, but rather the instantaneous change in that x point, okay? So basically, if I place the grid in here, basically here we would have x. We would look probably something like this. Let's say this just goes up even more. And now let's say this is x, and this point right here is going to be x plus h. Now we know there is a distance h here, but we want to bring these points together so that h is a pretty small number. Now we know if we do that, for example, if we try to find if we do this with a function, and now we try to compute the slope of this line, how much would that be? So in this case, we know it would be y2. How much is y2? It would be f of x plus h. So we would have f of x plus h minus y1. How much is y1? Well, we know it would be the shortest y value that we have, which is f of x. And now we want to divide this by our run, okay? Which is going to be our greatest x value, which is x2, so x plus h minus, I'm going to place the parentheses so you see it, but it doesn't really matter, minus h. And now this is basically the same thing as if we set y2 minus y1 over x2 minus x1. Basically here, just so you see it, this is going to be x2, this is x1, this is y2, y2, and this is going to be equal to y1. Now, once again, what I said before, what if we bring the distance between these 2 points and therefore the distance between these two y values very close to 0? So what if we basically said the limit as h is approaching 0 in this slope right there? Which is basically as if we said that, what if we say, I didn't place the 0, yeah, I'm sorry. What if h is approaching 0? What is the limit? So basically we're saying that what is the limit as the subtraction between x2 and x1 is approaching to 0. And therefore, since the outputs that we have correspond to this, and the difference between these outputs also correspond to the difference between these x values, the top part of our fraction is also going to be approaching to 0. This part that you have right here, that is a derivative, okay? A derivative is basically computing the slope when you have 2 points in a curve and you want to bring these 2 points very close to each other so that you convert a secant line into a tangent line, okay? So you have the points and you want to bring them together so that they basically meet with a very infinitely short space between them in 1 point. And how do we represent that? Well, we say the limit as the distance h between the 2 points is approaching 0. And then we just simply use this equation. We say y2, so our most or our greatest point in y, minus our smallest one divided by our greatest x value minus our smallest x value. This is what a derivative is, okay? A derivative is a limit. That is why in calculus you're gonna see limits first and then you're gonna go with derivatives, because you cannot understand derivatives if you do not have a clear concept of limits, okay? Now go on to my next video and I'm gonna show you now the formal, or well, this is the formal definition of a derivative actually. But now I'm gonna show you the definition that you might find on the internet. The direct equation that you might see, which is, maybe if you already saw it, it's basically this equation. But go on to my next video and see what I mean by the definition of a derivative, okay? So I hope you guys enjoyed this video and see you in the following one, which, well, you should continue right now, okay? I'm cutting it right here because the video might be getting too long, but I'm going to continue, okay? So see ya.